And now the one sample t-test. So far I've talked about z-tests and t-tests. Z-tests are commonly done when the population standard deviation is known. T-tests are commonly done when the population standard deviation is unknown. We use the t-distribution in these cases because the unknown population standard deviation is now a value that we must estimate. We don't know it, so we have to put in an estimate for it. That's why we have this new distribution instead of just using the z-distribution. So here's a question we could do a t-test on. In the population, the average IQ is 100. A team of scientists wants to test a new medication to see if it has either a positive or negative effect on intelligence or no effect at all. A sample of 30 participants who have taken the medication has a mean of 140 with a standard deviation of 20. Did the medication affect intelligence? So we're going to answer this question using these 7 steps with an alpha level of 0.05. Notice that we don't know the population standard deviation. We only know that the population mean is 100. We do, however, know the sample standard deviation, which in this case is 20. That's why we're doing a t-test instead of a z-test. So step 1 is for us to define our null and alternative hypotheses. Then we will state the alpha, calculate the degrees of freedom because this is a t-test, then state the decision rule, calculate the test statistic, state the results, and state the conclusion. So let's get started with that. First, we're going to define our hypotheses. In this case, H0, our null hypothesis, is that the mean is equal to 100, because in the population, the average IQ is 100, so that's what we would expect the mean of this sample to be. H1, our alternative hypothesis, is that the mean is not equal to 100, because we're testing to see if it's any different from the expected value of 100. Next, the alpha level is just 0.05, because I said use 0.05. Now we're going to calculate the degrees of freedom. Now calculating the degrees of freedom for a t-test is like this. It's just n minus 1, same thing as it was before. We have 30 participants, minus 1 is 29, so this t-test has 29 degrees of freedom. This has an effect on what critical value we use, which is going to be coming up in just a bit. Step 4 is to state the decision rule. Now we have an alpha of 0.05, so we want to find the middle 95% of where we would expect the mean to be. If it's outside of that in this two-tailed test, we're going to conclude that the mean we have is strange and likely is different from the population we're comparing it to. So this is our t-table. Remember that our alpha level is 0.05. This is a two-tailed test, and it has 29 degrees of freedom. So you can see I have 0.05 and 29 marked in red. And now if we draw the arrows over here, this is the critical value we're going to use. We're going to use 2.0452. And that's how I found it, using the alpha level and the degrees of freedom for the t-test. So that is our critical value. We would expect most values we calculate to fall within negative 2.04 and positive 2.04. If it falls outside of that range, we're going to conclude that our sample is different from the expected population. So now our decision rule is, if t is less than negative 2.04 or greater than positive 2.04, we're going to reject the null hypothesis. So now let's actually calculate that t. And it uses this equation right here, where the sample mean is 140, the population mean is 100, the sample standard deviation is 20, and the sample size is 30. So I'm just going to plug those things into the equation, and that's how I get a t of 10.96. I'm going to go ahead, but if you want to write that down, you can pause the video right here and come back to it when you're done. So the next step is for us to state our results. Now remember, our decision rule was, if the t was less than negative 2.04 or greater than 2.04, we're going to reject the null hypothesis. And we found a t of 10.96. That 10.96 is definitely greater than 2.04, so we're going to reject H0. We're going to reject the null hypothesis. Now our conclusion, or what this means, is that medication significantly affected intelligence. Basically, it did something. It changed it from the expected value of 100. In this case, it was 140, so it looks like it went up a lot. We can't really say that, but it is different from the 100 we thought it would be. And then I have t equals 10.96 with p less than 0.05. That's just the official format for stating the results. If your teacher wants you to do that, you can do that. If you don't, then you don't have to do that. But that is how you would write your conclusion. And that is a one-sample t-test.